It's weird to be sitting and talking. I pace all the time. Is anyone here who's in my class earlier? I'm sorry, I just realized this is being recorded, but I am so terribly informal all the time. Did I sit down at all during the class? Yeah. All right. So I'm sitting in a comfy chair. I have no idea why I'm moderating this panel, but I was asked to. I strongly apologize for how informal I can be sometimes. But let's go ahead and have each of the panel members introduce themselves, what your role is in the C world. Actually, what is the actual title of this panel? C23 and beyond, for what you did not hear here. Okay, so, well, I almost feel like it's unfair to have JeanHeyd introduce himself first. So let's start on the end and come back this way. Okay. Robert, if you don't mind.
We'll start with the bit players and work towards the king. So I'm Robert Seacord. As of this past Tuesday, I'm convener of WG14.
And that is the C Standards Committee?
C Standards Committee. I'm already behind in my responsibilities. It didn't take long. I'm 40 years in the software industry, which means I'm also fairly close to my death. And I've done some books on secure coding and C and C++, effective C, stuff like that. Probably 20-year member of the C Standards Committee.
Okay.
Yeah, it creeps up on you.
Wow. All right. How do you pronounce it?
Olve.
Olve, okay.
Yeah, I'm the odd one out here. I'm probably invited here to break the stereotype of a C programmer, I guess. But no, I'm not involved in the standardization committee, but I did actually host the April 2015 meeting at Lysaker, so that was, so I have been involved somehow. But I've been using C since, well, more than 30 years, 32 years, I think, and I've been teaching it for the last 20 years. And I'm also doing a talk tomorrow where I try to cram everything into 60 minutes. So
the entire C standard into 60 minutes?
Yeah, basically.
Okay.
Yeah. Well, just the language part of it. So, but mostly I represent some of the users here. I have been working with code bases with 30 million lines of C code, and the last 15 years, small code base with 5 million lines of C code. And now I'm not working so much with C anymore.
Thank you, John.
I'm John Regehr. I'm a computer science professor at the University of Utah in the USA. I guess I've been writing C for about 30 years as well, although I'm not on WG14, so I'll certainly defer to the experts for stuff that matters. But I've worked on undefined behavior quite a lot. I'm basically a tool builder. My research group builds tools, and a lot of them sort of center on compiler optimization and finding bugs in compilers and these kind of things. One of the things some code we wrote sort of in a very, very roundabout way became part of the undefined behavior sanitizer in LLVM, for example.
I'm sorry, when you say you work around, do we blame you for the undefined behavior?
No. I just try to annoy people with it.
Oh, I see.
It used to work better 10 years ago when people didn't understand undefined I sort of try to wash my hands of it more than annoy people with it.
So what name are you actually going by at the conference?
Yeah. So I have one too many aliases. So my name is JeanHeyd Meneide. I'm I guess still technically a student from the United States. I've been perpetually a student because like my life, when they say life comes at you fast, but then like life kept coming at me fast, and it kind of didn't stop coming at me fast, and so I've just kind of been this very long tumbleweed of being a student for a very long time. But I've been doing standardization stuff and working on all sorts of projects for a very long time now. I used to think it was not a long time, but then I remembered that I've actually hit my 30s now, and I've actually been doing software since I was like 19, so oops. I guess my most official title is the project editor for WG14, right? So when changes happen to the text in the standard, that's my job, right? So people write papers, we argue about them for a long time, and then finally, when we finally get the magic words that are supposed to dictate what goes on in the magic sky document, they get sent to me, and it's my job to put them in that document. So that's my job-ish now. It's not really paid for the last 4 years. And it all kind of happened because I got too angry at like C. Like I was like, why are things like this? And then I kept asking that rather than being like a normal person who like stops when they get an answer. I was like, okay, but why is it like that? And I just kept chasing it until like, oops, I'm responsible for this document now. Yeah, that's how I got to where I got. And then of course, I do a lot of open source programming, and recently did a little bit of Rust stuff, and that exploded a little bit, so I'm back to C and all this other fun stuff. So yeah, that's how I ended up here.
Thank you. Okay, so I have a list of, I have a little bit of experience interviewing people, so I have a small list of things that I have, and I have a list of questions that were sent in. Now, if anyone wants to ask questions of the panel while you're here, there's a roving microphone right here. And just raise your hand, and we'll make sure that your question gets asked. Otherwise, I will go through the various options that I have not yet had the time to look at because I was given them and then dinner came. So, like I said, just raise your hand if you have any questions. But let's go ahead and start with the first question that I have on this list, and it is about C lambdas. Oh, no. So, are C lambdas in the works? I remember hearing something about this personally a while back. Are we going to get lambdas? What does this mean?
I guess I'll take this one. So C lambdas were in the works. They were in the works for a while. Particularly by a man by the name of, maybe you've heard of him because he's written a book, Modern C, called Jens Gusted. Jens Gusted, prolific contributor to Musil, the Musil libc library, and a bunch of other stuff. Very good with macros, formally defined a bunch of stuff, wrote a bunch of blog posts and everything, and then got involved in standardization because, like me, he kept asking why are things the way they are, and then accidentally tumbled into, oops, I'm now maintaining a lot of this stuff. So Jens was working on lambdas for C. In particular, he basically just cribbed most of the design straight out of C++, and he wanted to put it into C. Everything from auto parameters, capture lists, all that stuff. But we were struggling in particular with how do we define the auto parameter part. So if you have a function and you have a parameter with auto in it, and you say you want to pass an integer one day and then a string the next day, how does that work in C, right? C doesn't have templates, it doesn't have that kind of genericity to it, so how do you make that work? And so it felt a lot like we were trying to write a lot of specification around the idea that we didn't have templates and we didn't want templates, but we basically had a feature that was like templates. And so that effectively sucked a lot of the energy out of the proposal and kind of got it bogged down. So eventually, near the design cutoff, or just after the design cutoff, where we stopped accepting new papers, there was kind of a very firm vote to say we're going to defer this till after C23. We can't figure this out. It's too thorny. We got to do a little bit more work, especially if we're going to have this newfangled auto that's like templates parameters, but we don't have templates. So how does that work? And so, it was. That's why you don't see it in C23. It won't be in the C23. That's going to be ratified in 2024, which is its own story.
Right.
But yeah, I made the incredible mistake of saying that I would pick up lambdas and all that fun stuff for the next version of C. So it is now thoroughly my job to figure out all of that stuff. So in particular, nested functions, blocks, statement expressions, and lambdas, all of those things that are basically about the idea of how do I execute this stuff that also references a bunch of data that didn't come in the form of parameters. That all is going to be wrapped up into kind of a gigantic proposal that I'm going to clean up and try to submit for C, so that everybody, that we can finally stop using things like nested functions that use executable stack and all this other stuff that people rely on, and unfortunately doesn't work everywhere. Yeah.
Thank you. Anyone else have any other comments on lambdas in C that you want to?
That was a very comprehensive answer.
Okay.
Well, I remember first time I heard about it, I thought it was a ridiculous idea. I think I still do. Because programming languages is basically a communication tool. So we need to make sure that it's easy to communicate both with computers and others, our intent. But then I saw someone saying, well, it could be a very simplified function without a name, and it might be done. I look forward to see your results. But currently, I'm still leaning towards it's a ridiculous idea. As a user, yes.
We had a proposal for defer mechanism, sort of an invention to add to C. And
this is effectively like a destructor from our C++ description. Am I thinking of the correct thing?
It's sort of taken from Go in a way. So
Okay.
You basically create an object and then you defer, the destruction of it, and then you, when you exit a block, you destroy them in sort of the reverse order they were created. And we got a working group approved for it, and I got a paper number and never wrote the paper because I like to kind of focus on what's in front of me, which was C23 at the time. But we might resurrect that. And one of the things about defer, it really would benefit from a lambda and some other C++ features. So yeah, hopefully lambda is something we can progress for the next standard.
Oh, wait, hold on. So before we go to the next question, I totally would like, for anyone who's watching this and anyone who's in this cloud, a lot of people really, really, really hate lambda's capture lists and the way you stick like things in the list. And that like, we're all friends here, so like I hate it too. I hate that C++. I hate the way C++ does it, but it's the only programming language that's figured that out, right? Rust is struggling with this with their async functions. Blocks have a lot of interesting consequences for it that create, like runtime baggage, basically, which is sort of unacceptable for C. Nested functions just kind of refer to things that already are there, and if you like exit the function, it'll just blow up, or reference data that doesn't exist anymore, which is just, basic use after free kind of, or reading, writing to the stack that's not there, just kind of stuff. So all of that to say, if you have a better syntax, please, 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 please send it to me. Like, I don't want to be on. I'm going to be in the firing zone for this soon. So, like, if you can send me some tips, some help, like, maybe you have a C-based idea that's like much better. Like, I'd love to hear it. Please save me.
I have a question. It's not any of these things that I planned, but since no one else is speaking up. You kind of offhanded said inner functions. I heard inner functions. Is there a question back there? Oh, well, I still want to know the answer to this question. Are you talking about actually being able to declare functions inside of functions in C, not just lambda functions inside of functions?
Oh, so the lambda proposal would work anywhere, right? You can just declare lambda file scope, lambda. You can declare them anywhere an expression is available, right? So you could do like in the middle of a function call, in a for loop, right? Whatever.
But we wouldn't be able we can declare, but we wouldn't be able to define a normal free function inside of a normal free function inside of C after this.
No, that would still remain valid.
Okay.
Yeah. So like we wouldn't be stomping on any of those existing extensions, right? So nested functions as they're defined by GC as an extension would still work.
Right.
And also declaring a function inside of a function that as like a way of pre-declaring a function would still also work. Yeah. So none of that is being broken. We're not going to. We go out of our way to make sure we don't break existing code, no matter how silly we think it might be.
Okay. Sorry. Go ahead, please.
So, people understand me?
We are.
Okay. As you might probably know, I've been doing a lot of C stuff in my career in former times, but now I'm kind of stuck in C++. And I've been coming along with all the changes that are coming with C and C++. And I was really happy to see that all the divergence that had evolved over the years the gap has been coming a little bit closer over time. And now, if I look at the proposed C23 standard, and I see a lot of stuff in there, and I'm not sure if we are now again widening the gap between C++ and C. So I want to understand what your opinion on that kind of thing is. If you don't know, who else does?
Right. I guess I should answer this question because I also did that. Again, remember how at the beginning I said that I keep chasing things all the way down to the logical conclusion? Well, I also signed up to be the chair of a group called SG23, we're Study Group 22, and the whole point of that group is compatibility with C and C++, and so that's like my job now. Again, unpaid. Damn it.
You should work on getting more paid jobs, I think.
I do. So that's my job now. My job is to make sure that C and C++ don't like strangle each other and destroy each other in the race to be a better version of themselves, right? Of course, this has people on both sides feeling very weird. On one hand, I've got a long list of complaints from people in WG21 in C++ side of things who are like, I can't believe C is doing all these moves. How dare they? Like they're going to depart from the things that C would want to do, and it's like, you guys have had a 20-year head start. What are you talking about? I mean, I can't tell them that. I can't send them an email saying that. That's not like a good thing to do. But like that's how I feel inside. Like, come on. But also, you have people from the C side who are very worried that like an avalanche of C++ features is going to tumble down and destroy the foundations of C, and turn it into they're going to put I get all sorts of things like we're going to put our template meta fetish into C, and then destroy it with all this complexity and everything, and it's like I have no intention of doing that, but like that's the fear, right? That's the fear that we're going to kind of make the two either converge in a horrible way that it destroys both languages, or that we're going to make them diverge in a way that makes it impossible to keep up. And the good news is that no, there's not really much, there really isn't that much of a surface of difference between the two languages right now, and that we plan to have in the future. A lot of the things that were different between C and C++ are actually actively being worked on right now. So compound literals is one thing that C++ does not have. That has a paper out for it, and they're trying to figure out the proper semantics for it. There's designated initializers, which I think C++20 added a semi-watered down form of it. C is a little bit more powerful, and by powerful I mean there's more foot gunny in that you can reference things that like uninitialized memory and like from the middle of the struct and blow your leg off, but like if that's what you want to do, be my guest. So that exists, and it's a thing that you can do, and so it can work. There's also just like a couple other smaller things about like, when you make a car literal with single quotes and you put like a thing in there that's like int in C, but it's like car in C++, and like there's small differences like that. Aaron Ballman actually wrote a huge paper called C XOR C++, where it tells you about the actual differences between the two. Again, I wish Aaron Ballman was here because he would be all over this question. But a lot of the differences are kind of like minor or smaller things, like how promotions work in certain cases, how argument conversions work in certain cases. But a lot of the bigger things, like we've done a lot of work to make sure that that's harmonized. So like your code won't be breaking between versions and won't be breaking between the two languages. And also, again, because there's these active efforts in C++ at least to standardize some of the most salient things that people would use, I don't think we're going to be seeing divergence anytime soon, right? There's an active component of people who want to make sure that the two languages work. There's active investment to make sure the two languages work, especially for headers, because again, there's shared headers. You can compile most C code as C++, that sort of thing. And then, of course, your vendors are also incredibly interested, right? So even if we get it wrong, right, GCC will, put compound literals in their C++ mode and tell us to go pound sand if we get it wrong. So that's how that works. So there's vested interest in making sure that we don't ruin things for people. Yes. Yeah.
Go ahead.
I would like to attempt a historical perspective to it, and then you can correct me. But there used to be a time when the C standard committee met the week before the C++ standard committee, and they usually went to the same place. I think that stopped just around 10 years ago, and maybe more. And the languages has basically seem like they have kind of given up to be the same language. I think that is a good idea, because being tied up to a big boat that might sink, or be a big boat having to take care of a small boat, and I'm not saying who is the big boat or the small boat, but they might sink together if we make them too close. And I think when I see the C23 that I'm a bit worried that it's too much eagerness to become C++. I like C++, I like C, but they are different languages, and you typically use them for very different purposes.
I think a relevant comment or question would be, so those of us who are C++ programmers are probably used to this 3-year release cycle, 20, 23, 26, we know is being worked on right now. Is there a similar release cycle to C?
Yeah, I'll take that because it's probably might fall under my responsibility, but so as a committee, we have to always be working on something or be canceled. And you can kind of dodge around that by working on technical specifications and things like this. But, you know, we've had a lot of discussions about the next plan, and I'm not sure why, because I made up my mind quite a while ago. And one of the discussions is, should we do a defect-only release, or should we do a defect and feature release? So I only want to do a new feature and defect release, because if you only do defects, now you've restricted the range of your solutions, right? So you can't invent something to solve a problem. So why walk into something like this with you know, arm tied behind your back? For schedule, I'm thinking we can do a 3-year work product followed by a 3-year standard schedule. And what I'm thinking right now is that that's what we'll try. So we'll do a 3-year work product. That gives us 3 years, and then after that we'll start a 3-year project to do the standard. So that puts the next standard in the 3 to 6 year range.
Okay.
And that's something the Standards Committee, C Standards Committee, has never accomplished before. I think usually we're 10 to 12 years between standards.
Well, there was a, what, C17?
There's C17, but
right?
that's an anomaly, because C17 is not a new standard. It's bug fixes for C11.
I see. Okay. The main reason I thought this was relevant was basically when is the next chance to sync up effectively, if there was, yes, question from the audience. Mike's coming around.
Thank you. I want to have a follow-up question, actually two, if I may. So we talk about like that C and C++, two different languages, and they clearly go to two different directions. C++ is moving more modules, const expressions, more like reflection maybe at some day, but it's basically avoid of macroses, yes? And C23 introduced embed keyword, which in C++26, for example, would be const expression function, so it's clearly two different ways. So my question is how we kind of keep a line on that, because I'm guessing that, I see that the C++ doesn't want macroses, but you kind of introduce new of them. And the second question is follow up with what Olve said about the sinking the boat, is now we have a lot of competition, like Rust, like Go, and why should I use C to start a new project instead of Rust or Go?
Who wants to take the why should I use C to start a new project question?
I can try.
Go for it.
But
You should go first.
Get started.
Okay.
Get started. We'll
Yeah,
clean
it's.
up.
I think I hear that question a lot, and I kind of feel it's an irrelevant question, because very often you don't start from scratch with a new thing, big thing. You might get involved in continue developing the Python language, which requires you to know C. Maybe you get involved in operating systems, Linux, for example, and then you need to know C. And so you just go on with microwave ovens, with guidance systems on missiles, on supercomputing, and on things that we send into space. You're often working with an existing code base, and existing tools, and an existing community, and existing books, and courses, and all of that. So just focusing on the language completely misses the point. And that is what I usually say to those who are so enthusiastic about Rust and Go, is that, yeah, they are beautiful languages, but they lack everything else that is important for a programming language.
But I specifically ask about... Is there? Yeah. I specifically asked about the new project. I understand if you join the company and you continue doing something was in C or wherever it is, that's perfectly fine. But my question is about the new projects.
Okay, let me just finish that one then. Because introducing a new language into an organization is also bad, because someone has to maintain it. So that's the reason why I'm kind of holding back on this thing. I think it's an irrelevant question. Well, I like your question, of course. But if your question is, do you think Rust is a nicer language than C, then I would say, yes, of course it is. But it lacks everything else.
Well, so the simple answer to your question is that there's no particular reason why you should use C to start a new project. I mean, it really depends on the properties of the project, what you're trying to achieve, where your expertise is. C may not be appropriate. If your new project is a web backend, C is a poor choice. Maybe Java is a better choice. So, C has a niche still. It's kind of it's a sharp knife for bad children. And if that's your project, then maybe it's the right tool.
But also, even now, even in 2023, there are plenty of chips that are targeted by a C compiler that aren't targeted by, these other languages. So that's sort of obvious, right? But C is just incredibly ubiquitous in the targets that it's for some random PIC microcontroller, it's probably the only game in town.
Could we argue that C is the most portable language right now?
Oh, it's not an argument.
Yeah. Okay.
It's not an argument. Like C is the most portable language right now. Like I have somebody, there's a meetup I go to around my home. Somebody's trying to use an ESP32 machine. Rust is starting to target that class of machines, but like the support is spotty. Compiler failures, right? Things don't work. A lot of things don't work, right? So it's really this idea of, is the support there? And then even after the support is there, like, do you have the engineers for it, right? So like, yeah, I'd love to use Rust on, my new crazy web backend for this bank or whatever, right? But guess what doesn't have all the things I need for that right now, right? For also another thing, especially for a lot of different domains, like whether or not the tool chain has been certified, whether or not the tool chain has been actually like, you can use this for this kind of purpose. Rust started to get there, right? And they're trying to work on like Ferrocene is a specification that was meant for the purpose of actually specifying the Rust language in such a way so that you can kind of reliably use Rust version X.Y for aviation, for medical devices, for this. But you have to be able to actually specify the language, which they didn't finish doing yet, and then you have to actually get the tool chain certified, and that's a bunch of different steps, right? And it's not just the compiler, but also the libraries, right? And remember that a lot of Rust, especially for its libraries, pulls from crates.io and the crate system, and so you need to be able to audit and certify a lot of those crates. And so again, what would normally be for C and C++, a lot of the idea is we'll just use a standard library and we'll build on top of that, right? So if you get your compiler and your standard library certified, right, you're set, right? Maybe you get some other stuff certified as well, but like once you get that certified, you're set, right? Say pick musalibc off the shelf for the libc, you get libstd C++ or libc++, right? And then you're set, right? You can start doing stuff. You decide you're going to do that with Rust, you have to pull down a bunch of crates, right? Lock all the versions down, right? Which you can do with crates.io already, right? But then after that, you have to go get all of that stuff certified, and that costs money, and it costs time. And can your project afford it? Can your project afford the time to do that, right? And so again, it's something that takes a lot more investment, and it will take a little bit of time before we start seeing those kinds of projects going. But I mean, there are people investing in it right now, right? Like I was going to help write a Rust specification specifically for that purpose, like not specifically for that purpose, but for like start kickstarting that kind of stuff. And so it's not there yet. People are working on it, and it will succeed eventually, right? And you will start to be able to get that. But as of like right now, right, especially if like I have a product I need to ship in 5 years, like, it depends on, again, like Robert and other people said, it depends on so many more factors than like I like the language, right? Because there's a lot of stuff I can like about the language, but like if it's not ready for the product, it's not ready for the project, right? So yeah, it's all those sorts of things that kind of factor into whether or not I can use this thing for what I want to. That being said, given the vulnerabilities that were just found in WebP and Image.io, there's a lot of companies that should be considering using Rust for instead of writing the world's most awful C.
Or at the very least, fuzz your libraries.
So funny story about that. WebP was being fuzzed, just not deep enough to hit the Huffman decoder issues that allowed somebody to remote code execute on, various devices. So it depends on the quality of fuzzing. It depends on, there's a lot of different factors, right? So sometimes having a robust field of tools is great, but if you're not using those tools to great effect, maybe you should consider moving to a different language where those tools are built in and you can't get past the compilation stage unless you satisfy those requirements. And so, again, you won't get things like out-of-bounds check that result in remote code execution if you're using a better language.
Anyhow, I think, I thought Jonathan had one earlier. You gave up? Okay.
Okay. Speaking of, actually, tying all of that together, you said certifying your libraries, your compilers, all of that stuff to be able to deliver a product, which brings me over to John. Because fuzzing things, fuzzing compilers, fuzzing standard libraries, what is actually the state of the art today?
That's tricky. So I like to write a lot of domain-specific little fuzzers. And so how many people, do we all know Marshall Clough here? He and I sort of hit it off really well because he and I sort of have the same approach to, you don't trust an abstract data type that you've implemented until you've written a specific fuzzer for that thing. You've written all sorts of invariants. You've looked at all the coverage. All these different. It's not really just fuzzing, right? It's fuzzing plus coverage plus much stronger oracles than just waiting for it to crash, right? Waiting for something to crash is just the weakest possible thing. And almost a large majority of the actual CPU cycles that get spent fuzzing things in the world are just waiting for it to crash. And this is just ridiculous. So the state of the art is I find sort of a very tricky thing because for something like, anytime you can get a better handle on the problem, on what you're fuzzing for, you start adding invariants and then fuzzing for those, and it just becomes unbelievably more powerful and interesting of a task than just looking for crashes like libfuzzer or like OSS fuzz is kind of natively trying to do. And if you pull AFL off the shelf, it does the same exact thing. It's just waiting for the OS to send a seg fault, and all manner of things can go wrong, and you don't get a seg fault. And so the state of the art is, I find it, like I say, very, very, very tricky because it requires a lot of application knowledge, a lot of domain knowledge, a lot of, it's not just this, we want it to be this technique that you can pull off the shelf and use, and in my experience, it just really isn't. And so you really have to, sort of deep domain expertise really pays off, and the best people to fuzz then, of course, are the people doing the development. And so these are the people, so much of the fuzzing that's happened in the world is done by these projects like OSS fuzz. I mean, I think by cycles, probably this dominates. It's not by the developers. And that's, of course, it's fine, right? The developers just didn't have time to fuzz WebP that much, and and maybe they should have, right? Possibly. But they're the best people to do it. They could have done a much better job, I believe. And almost everything is like that, where you have to get the people involved to buy in, because then also the bugs get produced close to the people who fix the bugs, and having that loop be tight and that kind of feedback cycle be close in terms of expertise, little networks of human beings and stuff, that really, really makes the process a huge amount more powerful. So when I do fuzzing, this is the only thing I'll ever talk about is being a tool builder, but I try to hand people tools instead of running them myself. Because if I run it myself, there's always some sort of a wall between me and them, unless I go work for them or they go and work for me. You really have to embed this stuff very close to the developers, and they have to sort of love it. And not everybody loves fuzzing. It's a personality kind of a trait. Like Microsoft has the program managers, the developers, and the testers. And to a large extent, these actually kind of reflect native human characteristics. And I just happen to be sort of a one, and I think many other people might agree. I just like to break stuff. I just need to break things, and I don't even like to build stuff that much. I just want to break other people's stuff. But when I do build something, I really try hard to break it, and it's just so much more fun to do that. And so I'm not giving a very good answer to the question, but because the state of the art is really very, I think, very situational and tricky and specific, and there's no recipe or anything.
Okay, then I want to follow up on my question. Because you said that the developers, the people who are actually writing the software, are the people who need to be fuzzing it because they are the people who are going to be fixing it, if I get you right. All right, so are the implementers good at fuzzing their own stuff? Because here we have multiple vendors, right, who are making the compilers and the standard libraries. And how well is that being done?
Well, maybe I'll just jump in real quick. Sometimes they're great at that. Like Marshall Clow, I thought he had the right mindset. Other times people just don't want to hear about bugs in their own stuff, or there's an ego trip involved, in which case, you know, it's almost like you become resistant to that. And so it just depends. It really depends. But I still think it's best if they can persuade themselves to be those people.
Thank you.
Oh, Peter already has a question. I mean, he literally just got off the train.
Sorry for dropping in late, and I just want to comment on what you said, right? Certification requires to certify against the specification. And the good thing about C and C++, we have a specification, which is even a law, international law. And I guess a lot of other languages suffer from not having, let's say, something you can certify against.
Languages that shall go unnamed. Nothing. Go ahead.
And that is a major, let's say, hindrance in adopting Rust in a safety-critical environment, even if you would like to do that.
Was there another audience question? No?
While you're searching for someone, can I give a third attempt on answering your nice question from Miko? If you start completely from new with a non-embedded thingy, yes. But if you are in embedded software development, then you probably have to deal with C and C++ still. And for those reasons explained. And also, if you are working on kind of typical desktop CPUs, then these languages work fine. But if you are working on more type of embedded CPUs, then maybe the only thing you have is a C compiler or assembler.
If I could just piggyback off of that a little bit, you know, the good news is that 10 years ago, right, when the big languages people were talking about, like Java and Go and those sorts, JavaScript and those class of languages, right? All the class of languages could never really touch C. And the reason they couldn't touch C is because their fundamental designs inhibited them from being able to access small embedded devices. And so people have literally tried to put these on smaller devices, right? So for example, device script is an attempt to put TypeScript on small things, but then you go through the list of features and you figure out that they had to rip out like half of the language in order for it to actually fit on the damn chip. So, you know, it's obviously there's always trade-offs, but one of the thing about C is that, you know, you can have pretty much 100% of the language there and a good chunk of the library there without, you know, butchering the language or like coming up with weird subsets or whatever, right? And to an extent, this is also true with C++, unless you also include exceptions in RTTI, in which case, because those are literally the only two features in C++ that that follow the kind of Java and JavaScript and Go and etc. Penalty in that, you know, you pay for specific parts of that language even if you never use anything related to them, and that's why they don't end up on these small devices that, you know, people talk about, right? And it's largely those two things are the actual absolute reason why, you know, it will never end up in the Linux kernel and it will never end up in all these other places, because from a design standpoint, there is no compiler you can build that will ever get it on those small devices unless you start cheating and do fno RTTI, fno exceptions, right? / you know, EC, EHC, I forget the MFCC flag for it, but, you know, you could turn off exceptions in RTTI and MFCC too. The reason that, you know, there will be a day when, like, you will be absolutely correct. We'll be able to, like, yes, we're going to use Rust, and it's going to go on this tiny 8-bit chip that has, you know, like 250, that has, like, you know, 50 KB RAM total, or sorry, not 50 KB RAM, like 50 KB like space.
Possibly.
50 bytes, 50 bytes of space total and whatever, right? Because as a language, Rust and Zig and
think a couple of other languages, right? The way that they designed themselves is that they are playing in the same court as C, right? C++ exempted itself out of that court when it chose exceptions in RTTI. Java accepted itself out of that court when it chose its huge object model. Same thing with Mono and C#, right? Even Mono, when you strip half the language out and you get it down to a really, really small runtime, it's like 5 megabytes, right? And there's like 1,000 devices in my head where I'm like, yeah, that's not fitting on that, right? Whereas C and C++, C++ when you're cheating, and then Rust, because of the design of the language, you can get it on that device, right? And that's why C, and to extension, cheating C++ gets to a place where they're not the only games in town anymore, because people are designing under the same constraints that you had when you have a C-style device, right? And so even though now we're talking about like, yeah, there's no way, right, just pick C, you're going to have to pick C eventually, right? That's the only compiler you get there. As backends keep coming up for Rust, the Rust C compiler, as backends keep coming up for all these different languages, you will eventually end up in a place where C will actually have genuine, like, native competition, right, from languages like Zig and Rust and whatever else, because they were designed in a way that doesn't add any overhead. The same way C was designed, and there's no magical overhead to the way the language is designed, right? And that was, again, 10 years ago, 20 years ago, that was a lost art, right? Everybody, even the D language, which was supposed to be a competitor to like C++ and C, had garbage collection, right? Like, and you can't get around that unless you literally turn off the garbage collection. But then D is a completely different language at that point, right? So right now we're entering an era where people are actually designing under heavy constraints. They're playing on the same court as C, right? C and C++ could just run circles around everybody all the time because they were all playing garbage collected basketball on the kiddie court over there, right? But like now, Rust and other languages are seriously playing on the same ball field, same ball, same rule set, everything. And so that's why you gotta, you're gonna have to be a little bit more careful in the next 10 years, right? And so that's why you just, it's not, again, like C isn't gonna like evaporate. It's not gonna be like a COBOL situation, but.
I know bank programmers who.
Yeah,
COBOL didn't evaporate.
Yeah, they didn't all. Much to a lot of bankers and and much to the happiness of certain programmers who understand COBOL and can actually program it, and they get paid, the gangbuster bucks for the stuff. COBOL still exists nichely, but like it's, like it's not something like you don't run into COBOL like as like a happy accident, right? It's like, oh God, you run to COBOL, it's like you've been briefed, you've been prepared, you've got your clearance, and it's time to start working on some COBOL now, right? Like that's how that goes, right? But like C right now, C is a happy accident, right? You pick up, a little bit of Java, look under it, oh, there's some C. You pick up a little bit of Python, oh, there's some C under it, right? C++, oh, we're calling into C code, right? Like, lift up a little bit of Rust, go into the unsafe, oh, what are we calling C code? Yeah. Like, it's everywhere, right? And that's going to kind of continue for a while, for a good long while. I said 10 years until the compiler's competitive, but, like, the footprint of C will kind of still be even there for the next 50 years. So, yeah. I hope that helps.
We had an audience question over here.
This is basically an expansion of what you said. You said like 10 years, 50 years, and Rust and embedded system. But do we think it will really happen? Yet from one side, Rust is designed on the same concept, being less overhead. But on the other hand, like Rust is fundamentally different. It is being designed as a safe language. Like C is unsafe language. It's not always bad. It's a superpower sometimes, especially in embedded devices. I don't know, like people can correct me. I have some experience, but not super professional one. But like if I want to light LED on a board, right? What I do in C, I write like an address constant, like I put a value there, like 1, and the lights go on. I can't do it in Rust now, and probably won't be doing it in 50 years if Rust would be a language, because compiler would not let me, like, you can't just declare an address and write some values there in Rust.
You can't do that in unsafe Rust, though, yes?
And this is another argument, right? Like, if you start using unsafe, why do you need Rust? Just use C.
Right. So, I don't know, maybe I don't know, you want to take it or? Okay, you don't want to take it. So, you're right in that, like, in raw Rust, right, before I turn on the unsafe block or whatever, right, I can't, just like scribble out an integer and then make a pointer out of it and then start writing to it, right? Obviously I have to drop it to unsafe Rust. But, and this was something that when I was actually because, you know, recently C and C++ came under fire because, what is it, the consumer advocacy group in the United States, the NSA, and a bunch of other people were like, yeah, this is some unsafe garbage that they're all doing, and it doesn't seem like they're going to change their ways, so we're going to start putting some pressure on them to do better. One of the things I did while I was researching I was going to write a blog post about the paper, but I'm wavering on whether or not I should, but basically while I was researching like Rust and Rust vulnerabilities and like where the vulnerabilities come from, like, what was it, 98% of the vulnerabilities I looked at Rust came strictly from their unsafe blocks, and specifically from their unsafe blocks is because they were calling into C and C++ code. But here's the, and that's the, but like all the other Rust that was there was behaving correctly, right? So you can imagine, like, yes, if I'm going to blink an LED, like, then I should be just using C. But if I'm going to be doing more than blinking the LED, right? If I'm going to be more than writing to the clock or hitting up a volatile pointer to check the register for this timer, there is an argument that 90% of the stuff I'm going to be writing does nothing to do with this kind of hard-tacked software stuff, or hard-tacked hardware stuff I'm doing. And that I could get away with squirreling that into very heavily audited and checked unsafe blocks, and then have the rest of the stuff I'm writing be safe. And that's an argument that you can make, and that's the argument that Rust people frequently make, right, when they talk about writing the stuff. But again, I don't have you know, hard numbers or anything, because again, I haven't finished that post is going to take me forever to finish making. But also, again, it's hard to quantify that and like really test it, because again, like, I don't have certified tool chains that I can access on for the Rust or Zig or any of this other stuff. So like, that's why I said, like, I'm not going to even bother answering the question until like 10 years from now, right? So, you know, again, and like I said, it's not like C will stop being used for this stuff, because again, like, you have to ship. Like, we live in the real world. We have deadlines. We have product we need to make. We have, you know, money that, you know, needs to fill exec pockets. At some point, I have to ship the thing, right? So I can't be like, well, we're just going to wait 10 years to eventually get a Rust compiler, and then we'll start the project. Like, it's not going to fly in the boardroom. So, you know, C is going to be there. But we do have to be wary that, you know, there is a future where this stuff will start to come under fire, right? And for good reason, right? And it's also, again, particularly because a lot of the C folk, not you, Robert. I just want to be very clear. Not you, Robert, and all the work you've been doing for security coding, but there's been a large section of the C community and C++ community who basically said, bah, security, who cares, right? And that really hasn't helped us. And so we have a large portion of people who had concerns, valid technical concerns about the way we're writing C, the way we're working with C++, and they kind of steadily escalated it up. And so now they're talking to consumer advocacy groups and everything, right? Because we didn't listen. And so, yeah, now the conversation is kind of a little bit out of our hands, and that's a little bit of a dangerous territory, right? Because now we're talking regulation. Now we're talking more serious endeavors. And so, again, this as like a more holistic view to all of this stuff, we will eventually have to figure out.
Okay, so I think John had something that he would like to.
Sorry, let me talk. Can I briefly,
go
before passing to you, Robert?
Sorry.
So just to muddy the waters some, you know, escaping C escaping C isn't the only thing you can do. There are tool sets that let you program C safely. And so JeanHeyd is completely correct that the you're not doing it right crowd is not helpful, right? But there are other people who make C safe. So, you know, for example, there's a company, TrustedSoft, that makes this tool that, you know, it actually, you know, uses kind of theorem prover level technology to sort of make sure that your C is safe. And, you know, at that point, the undefined behavior doesn't bite you at all because you've proved you've avoided it all. And, you know, so this is not standard stuff, and it's not easy to apply, but you can, with enough effort, apply this to a legacy C code base. And so, you know, the rewrite it in Rust is not, you know, of course, it's not the only way forward, and, you know, and it's you know, it's very complicated, and it's really is hard to say how this is all going to fall out.
And Robert, you had something to add to that as well?
I just wanted to do a quick plug following up on what JeanHeyd said, which is that this topic he's discussing about safety in C and C++ and consumer reports in the NSA, that's the topic of the keynote tomorrow morning at 9 a.m. So you join me for an hour. You know, we'll expand upon this discussion.
There's a question back there first, it seems.
So, because this has been way too nice and we need some flaming going on, what is his biggest misfeature and how do you fix it?
biggest misfeature of C?
C's biggest misfeature, you said.
Yeah.
Misfeature? Okay. Well, so Robert, let's start you and.
Oh God.
Pointers.
There's so many things. Yeah, I mean, I'm just going to say the first thing that's irritating the hell out of me lately, which is Realic. Yeah.
Realic. Oh, sorry. I was Realic?
Yeah, so we wrote Realic, and it was there for 30 years, and we all thought, yeah, that's fine. And then someone noticed that there's a Linux man page example of how to use Realic, and hey, it's got a double free vulnerability right in the example on the man page, right? And so I pointed that out to Nick Stoughton from the Austin group, and he went back to his constituents, and they came back with a wild chart about how every implementation did Realic entirely different, and none of the implementations match what we did in the standard. And so we went through some various iterations, and then we threw up our hands, and we made the behavior UB for C23. We just gave up. So it just surprised me how quickly that went to shit in such a short time. So it's kind of fresh on my mind. It might not be the biggest problem. It might be the biggest problem, and people might not realize yet that it's the biggest problem.
You know, I feel like I have to stand up in defense of Realic as far as Linux man page goes, because every Linux man page that I've ever looked at for a C function has at least a memory leak in example. Literally everyone. Shall we move on? Do you have a...
I like your effort to heat up the debates here, but so I'm not doing much of what you want here, because I think about a lot of languages and code as more like a beautiful church. You can't really, with some history, you can't really say what's the worst thing about this church or this building or whatever, because they are there for a reason. But if you look at kind of the worst, if I'm going to try and make an attempt, the worst release was probably C99. Because it introduced so much stuff that people didn't want to adopt. So it took so long for actually compilers and users to start using a lot of the garbage that came in C99, especially in the library. So the language, the core language evolved in the right direction with restrict and a few other things that was there, but the library introduced a lot of shit. Yeah.
Okay, John, do you have an opinion here?
Yeah, let me just go with a really narrow one though, so just to not throw too much fuel on the fire. It just super annoys me the way the order of evaluation of parameter lists is not fixed. This is just absolutely the most useless freedom that a compiler could ever possibly been given. Just terrible. Just go left to right or anything. You know, zigzag. It doesn't matter. Just do something. Anything would be better than just letting the compiler do what it feels like.
But in the context of history, that was allowed because we didn't know what order the parameters would be pushed onto the stack for our calling conventions.
Sure,
right?
but so pick a standard 89 and then pick a place where we just said stop.
Okay.
This no longer helps.
So like I have a gigantic rant about evaluation order that I could do, and I'm debating about whether I should do it.
Do you mean right now, or do you mean...
should I rant right now, or should I just like go do something else? Because I actually have other features I actually have the things I actually don't like, but like.
Well, my suggestion would be since JeanHeyd already, since John already said, well, it's your choice.
All right, hands up if you want me to rant. I'm gonna.
All right.
I was hoping you guys would bail me out.
You can even stand up if you want.
Okay. All right. So no, I don't need to take a minute. But we had a chance to fix evaluation order, not in C, but in C++. We had a chance to fix evaluation order. Gabriel Dos Reis, Herb Sutter, and a bunch of other people wrote a paper to fix evaluation order in C++.
With performance numbers.
With performance numbers, right? So they actually got spec and they benchmarked their own software, and with a typical left to right reading order evaluation for function calls, operators, you name it, the whole 9 yards. They figured it all out. They showed that even if you didn't do anything to your compiler, like you did nothing, and you just had left-to-right evaluation, you got plus or minus 2% in performance, right? Which basically meant it was random noise whether to go either way. And that was without touching your optimizer. If you actually started touching your optimizer, you could basically make that minus part go away, right? So they wrote a paper about this. They wrote a paper about this back in like 2015. And they put it in front of the committee. The committee was like, this makes sense. This is good stuff. This is good stuff, right? So they percolate through the committee. CS+17 is coming up, right? They're doing the 3-year cadence right now every time, right? So CS+17 is coming up, right? Things are going for final ratification. And some people have problems with the left-to-right reading order evaluation, for function arguments in particular, right? Because there are certain compilers that will not be named that had right-to-left or zigzag or whatever crazy nonsense they were doing at the time. Particularly right-to-left was the one. Now, CS+17 was going to publish, and they didn't want to actually, I don't know if they didn't have time or they didn't feel like it, like, I don't know, they don't explain themselves, sorry. They don't explain themselves, so they just kind of did the process thing where they complained through the proper channels, right? So when you're publishing a the CS+ or a C standard, right, you get this thing called national body comments. And so basically this is a chance where you get to start, you know, yelling about stuff that you don't like, and you can demand that they fix it. And so what happened is that, you know, through national body comments and other, you know, official channels, they complained about it. They complained that, oh, this might make us do extra work, we don't know if it's worth it, et cetera, right? So there's all this evidence that, like, left to right order evaluation is like, that is the right way to do it. That any other order evaluation is bunk, it's complete, it's hostile to the user, like, nobody expects it. When it finally happens to them, they lose their minds, like, you know, code that was accidentally depending on it breaks in half, like, it's a whole nightmare, right? And so if you just had left to right defined all the time, you would get it right. And their argument was basically, it's taking away compiler implementer freedom. That was their argument. And it worked. So it tanked specifically function order, argument order evaluation for arguments from left to right. And so what it was replaced with, because it's C++, right? So it's got to be the worst possible solution. It can be evaluated left to right, or right to left,
Or inside out.
or not inside out.
Not inside, well, in a circle or
in
whatever.
a circle, right? So you can start from the middle and go to the right, and then circle back to the beginning, and then process the rest of the arguments. But it always happens in order, and it's not interleaved, right? So those are the only guarantees you have. It's not. You can start anywhere. It goes left or right, and it will do a whole list, and it's not interleaved. And that's the only guarantee you get. And that's like the C++ wording they came up with. And it's just, it is the worst possible thing, right? And the crazy part is, like, because I keep volunteering for this crap that I shouldn't, I volunteered to put statement expressions in C. And it would have been great if C++, as an example, said, we have figured out the order of evaluation of stuff. So now, I'm putting statement expressions into C, and there is no guarantee when that statement expression in the middle of your function call is going to be evaluated, right? So, like, if you're referencing some, like, variable or some other thing that comes from some other part of evaluation, like, all of it's just unspecified. Yeah. So if you write a program that relies on, the, you know, specifically, you know, oh, the function call here relies on the fact that this statement expression fires first, then this statement expression fires first. Well, it's just unspecified, and if you rely on it, then you've invoked UB, and now UB sanitizer kicks your ass, and, you know, you get drop kicked by, you know, some use after free bug. Like, there's nothing I can do, right? And it would have been great if C++ actually set an example, but they don't.
So I'm going to go ahead and add to this as well. So my students that I had this Monday and Tuesday already heard me go on a 30-minute rant about how the C++17 requirement that each function argument be evaluated still has bugs in GCC. And it is specifically the reason I personally stopped submitting bug reports to GCC, because they didn't fix that one and I gave up. So, Peter, you had a comment?
Yeah, I just wanted to, how do you say that, to actually defend the right to left order and its history. I was suffering in 1987 teaching C with Nixdorf that had 68K machines, very nice stack-based, and RISC machines. And then you had that typical printf with several ++ i's, and you figured out what went wrong. But the actually right-to-left evaluation came from a time when you had tiny processors and just a stack. And you have that ... thing. So you have no chance to actually not evaluate right to left to get veridic arguments on the stack. And that's the only thing that is the history there. And maybe those vendors actually still support those tiny machines you claim C is actually doing. So maybe they have a reason to have this right to left evaluation. I don't mind about the inside out, turn around, or whatever, run a carousel or drive a whatever bumper car. But again, there might be a background reason. But again, I also very sorry about that. But we have many of those things that just didn't make it and fell into the cracks. And I tend to fight about that. For example, I got one feature into C that I got there deliberately in to get it into C++.
You don't know anything about
and
that.
I got feedback. Oh, now we have a new paper. We want to make that a keyword, not whatever I did there.
Yeah. So what Peter's was referring to was assert. If you've ever written the assert macro and you've ever put a comma in there, right? You've screamed because it sucks and it's not supposed to take multiple arguments, right? And so the obvious fix is to just make that, assert, define assert, and then ... right? So you could put multiple things in there and it just works, right? Because that's what why doesn't this work, right? Like, obviously, but, anyway. So Peter fixed that, and so we'll actually get to a place where you can actually have, like, things in assert that have a comma and it won't, like, explode or, like, deteriorate, which is great. And so that I believe, again, like he said, he only came down there because W21 got like cold feet and were like, oh, well, we'll just send him down to the C committee and he'll get stuck there. And it's like, surprise, I'm there, Robert's there, a bunch of other people are there, C is not dead, let's get this paper done. We got it done. So, yeah, thank you for submitting that paper. Appreciate it.
Are there any, yes, there are, okay.
Oh, well, if we did the rents, we should do the opposite as well. So C23 is out. What are your favorite things?
It's not out.
Well, okay, it's finished. It's finished.
It's balloting.
What is your favorite thing from the proposed C23 standard?
Pass. Just let me think about it for a minute.
Oh, okay. Well, who wants to start?
Or in a circle is fine.
I'm going to start with John then.
I haven't spent much time with it.
Oh, goodness gracious.
Sorry.
Am I the only one that has an answer to this?
I have an answer.
I'm sure we might be the same answer. Go for it, John. No.
Okay. So my favorite teacher that actually there's a bunch. Jesus.
Pick one. Give John time to think, and then we can circle back.
There are a bunch, y'all.
Okay, so because like there's things that I like for like selfish reasons, like obvious selfish reasons, and then there's things I like because like they're good for everybody, like all the time. So I think my favorite is actually memset explicit. It's a security function that it's if you've ever used like B0 memory or whatever that comes from some of the other libraries, or memset secure memset, or memset s. Sorry, yeah, I substituted in the full word secure, but memset _s. It actually will zero the memory for you, right? Very important for security and everything else, right? That only came if you had Annex K, right? And there was for a very long time a bunch of people who hated Annex K, who still hate Annex K, who want to destroy Annex K and everything about it. So it didn't exist on a lot of implementations, right? Or it existed in like under a different name or something special, crazy, whatever. So memset explicit is now part of, I believe it's stdlib.h or something like that. It's basically you include a normal header, you don't have to get any Annex K stuff, and you'll be able to securely zero memory, and that's great. So
this is a memset that's not allowed to be optimized out, basically. Is that's
yes.
the point? Okay.
Yes.
Okay.
So it's just memset _explicit. And there's a version that's going to go to C. They'll call it secure clear or memset explicit or whatever they want. I don't know.
Can I ask a question about that?
Yeah.
What's the story? I mean, the compiler could still have made a copy and you zero the original, but there could be sitting in registers and stuff. What's the story for that?
The story is complain to your vendor. But no, this actually did come up, right? Like when we were discussing security, it's like what happens if you have a shadow copy dumped to the stack, or something stored in a register, or how do you securely clear everything? And the answer to that was like, well, we really don't have a good answer for that at all anywhere, and not even existing implementations in their vendor extensions have a good solution for that. The best we can do for now is provide memset explicit, so at least for like heap memory and things like that, right? So where you usually store secret keys or whatever, that stuff works. That you can kind of have that work out. But people were thinking about maybe they should be using attributes, which were a C++ feature, also put into C23 that there's a standard way to spell attributes now. So open square bracket, attribute name, maybe an open parentheses and a bunch of arguments if you want to, close, double close square bracket, and that is a standard way to spell any attribute. And you can add your own vendor attribute. So vendors can start loading up like, I wouldn't recommend it, but have open square bracket secure, close square bracket, right? I don't know what that means, but like, a vendor can put that there and say, oh, we won't spill copies of this to the stack, or we won't, or if we do spill it to the stack, we'll zero it when on the closing brace or whatever. We'll make sure that this memory block is zeroed out or something, right? But that's something you have to argue about with your vendor, right? It's not something we don't have that in the standard.
Can I tell you what I tell students?
What?
When this comes up? I tell them you're not allowed to trust anything of that sort. They're going to screw it up completely. Do it in a separate process and eliminate put the secret in a separate process and eliminate it properly. It's the OS's job. It's not a language job.
Yeah.
So I
It's a
thought
good
of
thing to tell students.
my favorite C23 change.
Hey.
Which is, we eliminated trigraphs. So I even have that in my my profile. Slayer of trigraphs is my new title. But
was that just in bringing it in sync with C++?
Yeah, C++ did it first, so
Yeah.
that laid some groundwork.
But was it was part of the synchronization, I guess? That's what I'm asking personally.
No, not really.
Okay.
I mean, the prevailing belief in C is that because C++ did it doesn't mean we have to do it.
Right.
I mean, they're independent about that. I mean, there's this strong agreement to be compatible, but a lot of times we focus on header files. Is that going to go into a header file? Well, then we need compatibility. Otherwise, So the other thing I was going to say was attributes, except I pronounce it differently than JeanHeyd. I don't know why. It's always fun to hear how people pronounce things. Like Aaron Ballman is not here. I call Malik. He calls it Malak, which always sounds like a vampire name to me. So I'm always amused by that. But attributes, yeah, we're actually introduced by Aaron, and oh boy, yeah. Okay, I won't tell the story. But we tried to get attributes into. No, I'm telling it. We tried to get attributes into C11, and Herb Sutter, who had just put attributes into C++ 11, came into the C meeting and told us, why do you want a standard way of having non-standard extensions? And it managed to keep attributes out of C++ 11, so it delayed it for us for 12 years. So anyway, Aaron finally rectified that, and now we'll have it going forward.
Okay, I really feel like you should have said like the checked integer stuff.
Yeah, we have some checked integers, and they're based on the GCC built-in intrinsics, where you add, it's for addition, subtraction, multiplication. You perform that operation in assigned infinite precision, and then you produce a result. And if the result you return is the same as the infinite precision result, then you set a Boolean flag, a return value. So basically, it gives you an indication if you've gotten a mathematical result or not, and it can be extremely efficient because it's based on intrinsic functions. So that's kind of a nice start, and Andreas Weiss at Toyota is not actually here. I don't know why I pointed to the audience. We're probably going to work on something similar for C++, which would be become my first C++ paper. So I'll get exposed to whatever kind of hell that is.
So I think that, well, I have a question now.
I was going to ask you, what is your favorite?
What is my favorite?
Yeah.
Well, I'm pretty sure it made it into C23, but it would be embed.
Mine too, yes.
Right, yeah, embed. So, yeah, that was my feature. That was my long haul baby that I carried for way too many years. So embed was my very first C++ paper. The form that went to C++ was like a magic compiler intrinsic. So you said embed, you gave like a file name, and it would like produce magically a pointer to a data array that you could access that had the binary data from that file, right? And this would execute at compile time. That actually worked out really well. I implemented it in the compiler like a day. It was super easy. And then the committee got their hands on it. And they were like, well, this is problematic because what if somebody constructs a string at compile time and then passes it to this function, then now you don't know where that file comes from at compile time, and that makes dependency building hard, right? And so that triggered every single build tools person to come for my throat because I turned their beautiful hash include C++ fully predeterministic builds into hellscape because you could still embed something that you created from some strings at compile time, and who knows where they come from, and did you ship all of the files you needed right to your build server, right? And so you don't know if that's the case if you do that, right? So you can't quickly pre-scan all of your source and header files and know these are where all the files come from. I'm going to ship everything to the build server and let the build server do the work now, right? It was you're constructing these strings at compile time. Who knows what you're sending up? This is untenable, right? So that slowly morphed into this preprocessor directive called hash embed. And so it basically runs exactly like hash include, or I don't know, octothorpe.
Octothorpe. Just say octothorpe.
Octothorpe include.
Everyone knows what you mean with octothorpe.
Yeah. But basically it's a preprocessor directive. You give it the file name, and then thanks to some implementer feedback, you can also pass additional parameters to the embed directive to do funky things with it. So depending on your vendor, you might be able to do things like, I'm going to turn this, because it always generates a sequence of integer literals that are unsigned car sized, right? For everybody who's normal, that's 8. For everybody who's not normal, that's 16 or 32 or 9 or whatever carb it happens to be. But it's 2 to that number, right? Minus 1 or whatever. And you get that from 0 to that number, and it just produces that, right? And then the idea is that you're supposed to optimize that, right? So the way I specified it is that you can do this magic optimization where, if you realize that if it's the only thing included in, say, an unsigned car array, then you can basically just bit blast the data, right? And so I actually implemented that, and I did a bunch of benchmarks saying, you can make this stupidly fast. And so, what used to be a 15-minute build time to include this 40 megabyte, image that goes into the flash of your router so that you can quickly flash the whole damn modem when you, want to do a quick reset. That actually doesn't take 30 minutes to build anymore. That takes, a short amount of time, right? Literally, under a second each time. We were talking 0.1, 0.2, 0.5 seconds. And I benchmarked all the way up to including 4 gigabytes of data. Not that it mattered because MSVC died, GCC switched to swap and then never finished. Clang, I think Clang finished on the 4 gigabytes and then did the same thing GCC did on the 40 gigabyte test. So, yeah. But basically, hash embed allowed you to do all of that up to 4 gigabytes, and it was all under a second, right? And so you could include it, you could just have it there, it would be there. It would be available at constant expression time too. So as an example, say you are a person who works at a trading firm or whatever, right? And you have non-technical people who do JSON files or whatever, or other configuration files to give you the numbers, right? These are the parameters you need to tweak this model so that you can make stupid amounts of money per second, right? Before, that was stuff that usually came loaded at runtime, right? You would take the file, you'd load it up, you'd get the parameters, you store them somewhere, and then you'd use them in your algorithm, right? With hash embed, you can literally load the file off of disk. It's injected straight into your program, right? So you just rebuild the program, and now what used to be runtime configured stuff, it is now compile time stuff because these are numbers that your actual compiler can see and optimize for. So all of that stuff that normally would be runtime, and you'd have to use SIMD and whatever to get the actual performance out of it, and propagate those numbers, and propagate the assumptions that would come from those numbers, you now just get for free because the compiler can see those numbers and just start going ham. And so There's all sorts of use cases for this, right? You cannot use it in standard C++. I have strongly urged every vendor to implement it in both modes. I'm going to be putting a paper through C++ eventually, hopefully C++ 26. I've managed to pass the main design group for C++, so it's in what's called core. Core does wording, and then it passes eventually into C++. That should happen at C++ 26 time. But hopefully you'll have hash embed in both languages.
Do any vendors currently ship with support for it?
No.
Okay.
Yeah, no. So there are some C compilers that already implemented it. So there's some of the people who helped me when I was writing the proposal, who actually went and implemented in their in their compilers on my behalf. And they reported stupid speeds. They're like, yeah, we got 100x speed up in some of this file stuff nonsense that we were doing. And I was like, yeah, that's great. That was the point. Please believe me the first time. But it hasn't shown up to like the mainstream compiler. So I don't think MSVC has it. Clang doesn't have it. GC doesn't have it. I'm actually after this conference, I have like a week off, and I'm basically going to be spending that implementing embed in Clang, and then putting it in there myself because I don't feel like waiting for whenever the vendors, right? And also, some vendors are also complaining to me like, oh my God, it's hard to optimize. It's like, well, that's what you get when you turn into a preprocessor directive instead of the nice shiny built-in I made for you. But like, I'll optimize it and show you how anyway, and then I'll write a blog post about it. It'll be a salty blog post where I'll be like passive aggressive, like, yeah. So like, I have to go implement it and optimize it because apparently you can't. Duh. But I'll implement it and I'll get it shipped out in Clang. Hopefully before CPCon hits, it'll be in Clang. But.
Did you just volunteer yourself for more unpaid work, JeanHeyd?
I mean, yes, but like at the same time, like if I don't do it, who will?
Does anyone else know, now that you've had time to think, have a favorite C23 feature that you would like to?
I would like to mention that, well, in the intro that is now on the web, you have these fancy titles, and my title is Ministry of Silly Code Snippets. And but I could also mention that I was running the C++ pub quiz for many years at the Equinor conference, which Anders now has an even much better one. It's called cppquiz.org, is it? Yeah, CPP quiz. Go visit. So when I saw the C23 standard, or when I see any new standard, I look for opportunities for writing pub quizzes. And I found plenty in the C23 standard, really. But my favorite would probably be the explicit as well, because I was actually in kind of a crisis team in Cisco when we had released an open source product with memset that was compiled away, optimized away.
I think it might be worth telling the audience here, go ahead if you don't mind since you're in the middle of this, what is the problem with memset? Why do we need replacement?
Well, since C and C++ is defined by behavior, if the compiler sees that you don't, I don't need to do this, then it's not going to do it. And if you are memsetting, for example, an object of automatic storage duration, and just after that returning, memset will nearly always be optimized away now. And if you try to be clever and write your own memset, you are just waiting for the compiler to figure out and optimize it away. And this happens over and over again when we try to deal with it in Cisco. We eventually managed to create something that would be the same as the memset explicit. I think we called it burn. burn memory or
right.
Something like that. But it's now that it's in the standard, it's a very useful thing to be able to force some particular implementation, and basically tell the compilers to stay away from this. So, yeah.
Anything else, audience? We are about 4 minutes from when we're supposed to end. Is that correct? Yeah. We have one back here, it seems.
All right. So now that we have checked integers, would there be room for a specific limited form of overloading, operator overloading, in order to make them not obnoxious?
I think the answer is no. There's certain areas where the C committee doesn't want to go, and I think overloaded operators are one of those areas. Templates is not going to happen. Exceptions are not going to happen. Coroutines. I don't think we know how to spell coroutines. I don't think we've gotten the discussion even that far. But there's the C committee has kind of two parts, right? So there's kind of the progressive wing that JeanHeyd and I are on, where we sort of view C++ as an experimental language. So we'll look and say, they've done a few good things that have worked out, and we'll maybe steal those things. And then there's the regressive wing, and they're of the opinion that really we don't want anything to do with C++ at all, and many of the things we've done since C89 have been a mistake, and we should retreat. So that's kind of the core overall, right? So it's some features from C++ can be added, but it's quite an effort, it's quite a struggle. The lambda thing didn't make it. We got const expr, but only for objects. We didn't get it for functions. So there's more work to be done.
Go. You're on the panel. You can speak whenever you would like to.
Could I go back to just the specific question about overloading? That's a pretty interesting question, which is how explicit do you want overflow checking to be? And there's a different way to get the same benefit or similar benefit that's non-portable, which is, and this is what sort of Android has done in parts of, for some of the codecs, turn on parts of undefined behavior sanitizer in production. And Android even did this for unsigned overflow in some cases. So of course this is perfectly well defined in C, but possibly undesirable, right? In a similar way, Java made two's complement overflow defined, but but that doesn't mean it's what you wanted, right? It's still not intuitive to a lot of people. It's still not, wrapping around is just hard. It's hard for people to get our heads wrapped around it. So anyway, you can overflow check everything, and then you have to obviously test the hell out of it, right? Because you might, who knows what's going to happen. But but again, this if you have an Android phone, that's what's happening in some of the codecs. And so it's it's a sort of a very different approach to the checked to the explicit checked integers, and it's not in the standard or anything. But if you are one of the heavy hitters there, and you control the tool chain, then they apparently decided that was an okay option, and the security trade-offs were worth it.
To also, I guess, mention operators. So we actually have a proposal for operators in C that actually already showed up from, I do not remember the proposal off the name, but he works on a compiler for Windows, actually, a C compiler for Windows. He actually implemented it. There are some interesting technical issues that kind of come with the proposal for operators. So one of the reasons why you don't want operators in C is because they require what is effectively function overload, right? So you have two functions with the same name. How do you differentiate between them, right? So if you have two operators with the same name, how do you differentiate between that? This one works on integers, and this one works on, I don't know, double, or this one works on, my cool struct. And so that's where you get name mangling. That's where that comes from. So, you take parts of the type, or, parts of there's some kind of property of the different operators or whatever, and you, without telling the user, you graph them into the name for what comes out on the other side. And that way that, the front end knows it's going to be calling this messed up, funky name that you don't see, right? This, of course, has consequences, right? Consequences in, how big the symbol names, right? So in C right now, you write a function, you have a pretty good assurance of what that function is going to be on the other side, right? You might add an underscore, there might be some thing that comes out at the end, whatever, but you write a function, it comes out in your linker looking like the exact same thing that you defined it to be, right? Very simple. You add overloading, that goes out the window, right? And in particular, if you have overloading, you have to contest with the fact that there are existing implementations of overloading, particularly because of C++, right? So if I want operators, right, and I'm already an implementer that has a C or a C++ front end, middle end, back end, I'm not going to want to have the mangling in some simple form, right, that maybe a C programmer would understand, right? I want something that's compatible with C++, because that would work with what I already have, right? So now you're playing this game of okay, do we play to the strength of the C++ implementations that have these few C and C++ front ends or back ends or whatever, Or do we go with something that's more C-like that maybe doesn't require that? But then if you don't have that, how do you implement this, right? If you have operators, right, all of these functions have the same name, how do you actually implement it? I have an answer to all those questions. And I am so invested in this that I actually commissioned 2 separate comics, and I'm going to be writing a massive blog post about this exact topic, about how you implement operators in C without overloading, without name mangling, and any of that other stuff. It is going to be very fun and very spicy. It's also been very expensive to commission that much art. I've never actually done that before. But hopefully it will present a convincing argument that would actually make operators look viable in C. I don't think anyone from the committee will like it because, again, just as our nature, right, we have a C++ has done a lot of damage to the programming psyche. Right? In particular, one of their foremost sins has been operators, right? People do some interesting things with operators, and it has caused a lot of backlash hate. So much so that even James Gosling, when he was creating Java, was like, sure, strings have plus for concatenation operation, but other than that, you don't get operators. The rest of the standard libraries get operators. Nobody gets operators. And that's just how that works. And so that has caught on like fire through the entire programming community, right? A lot of people in C hate operators. A lot of people, whether it's Go or other languages, like just straight up hate it. Like, don't define operators, don't write them, don't do it. Even if your program has operators, don't define them, don't overload them, don't touch them, don't do anything with them, right? So you're not just combating the technical issues of like how do you address overloading, right? And because I'm going to write a full blog, like how do you do that without without name mangling and overloading? Right? How do you take away that issue? Even after you take away the issue, you're dealing with a social problem, which is they hate it. Right, so you have to convince them, right? And this is why we commission so much art. So hopefully it'll either make them hate it more or they'll love it, and they'll slowly come over to the side, right? Like I'm playing a dangerous game here. I know it's a long shot. I know it's a Hail Mary, but like the guy actually sat down and wrote a proposal about it. Right, N3054. He actually sat down and he wrote a proposal for it. So he deserves a actual like full technical like rebuttal that gives his proposal the best chance of having a shot at success, right? He did the work, so I should honor his work by doing the rest of the work myself, right? But, you know, it'll take a while.
Okay, so it's time to wrap up.
Oh.
Can people subscribe to your newsletter?
Okay, so there is a newsletter that I actually don't post in.
Actually,
Sorry.
what is your website so people can follow along?
The website that I have is the phd.dev, because before I was Bjorkus Dorcas, I was just the PhD.
Okay.
People got really upset by my name being the PhD.
What?
Because it implies that I have a doctorate, and it implies that I'm really smart, and so a lot of people think I'm like hoity-toity, like some like...
You
like
fully explained this on CBP Cast.
I do, but like,
it
it doesn't matter how many times I explain it, because people would see the name and they'd just be like, oh, it's that guy thinks he's smarter than me. You know, we're programmers down here, and it's like... I mean, some people say I'm smart, but like, listen, some of the decisions I've been making have been very questionable lately. But I mean, look at all the unpaid work I'm doing. Is that the work of a smart man? Like,
You're smart, but not.
Kate Gregory's right. I may not be wise, right? I think that, and that, I mean, I can't say I'm young anymore.
No, you can't. You're sorry. If you're over 30, you can't say it
yeah,
anymore. It's rule. Okay.
Okay. I'll come the kids keep and I'll learn how to be more wise.
I will go ahead and let's thank the panel for coming. And if you want to mob them afterward and ask questions, then you are free to do so.